Oh, hi everyone. We're just back here again doing some more on exercise 5E. We're having a look at question 18, which is very similar to what we did when we did our original calculus. So if we've got our function over here, which is xt, which represents a distance, what we have to do is find the velocity and acceleration functions for this body. So obviously we have to derive that, so the velocity being the first derivative for that function. So when we derive that, we're going to get 100. The 2 will go out. We'll be left with e to the minus t on 10. And then we times that by the derivative of that, which is minus 1 on 10. We can simplify that function there to be, the 10 will cancel out with 100 and give us 10. The 2 negatives will give us e to the minus t on 10. Now when I do my sign diagram for that, obviously for t, this is my v of t. E of t we know is actually always greater than 0, so therefore that's actually always going to be positive. Next we do our acceleration function there. So deriving this function here, we're going to get 10 e to the minus t on 10 times by minus 1 on 10, and that will give us, the 10s will cancel out, will give us minus e to the minus t on 10. So doing the derivative, the sign diagram for that, because we know that e of minus t on 10 is always positive, we know that function is always going to be negative. So that's part A done. Looking at the next part of that question, says find the initial positions of all those. So we know that x of 0, putting it into the equation, that bit up here will actually become equal to 1. So 2 take 1 will give us 1. So that's going to be 100 centimetres. Next, looking at the v of 0, that will be put into the original equation over here. So therefore we know e of 0 is going to be 1, so that's going to be 10 centimetres per second, and then putting 0 into the acceleration equation, we're going to get negative 1 centimetres per second squared. So going through the next part of that, part C, find the position and the velocity and acceleration after t equals 5 seconds. Alright, so might as well do that here so we can see that. So x of 5 equals, now the best way of doing this is to go and graph this, and then we can actually get that value. So if I go into my calc, so value, put 5 in, that's going to be 139.35. So going back to my equation, find the right document, so that's going to be 139.35 centimetres. V of 5, if I put that into that equation there, probably easier go again to your calculator and go and do your calculation for that 6, and we put in 5, so that will find the derivative, slope of that 6.07. So putting that back into our equation, 6.07 centimetres per second, and then A of 5, if I've got that, I might as well just use my calculator. That's going to be minus 1, so that's E. That's going to be e to the minus a half, isn't it? So minus 0.5, and it's going to be minus that, so it's going to be minus 6.07. So minus 0.607 centimetres per second squared. Oh, next part of that question then asks us to find t when t is equal to 150. Alright, so easiest thing here is to go to your calculator and go to your graph there, because we've got a graph in there anyway. Put 150 into there, graph that, and just find the intersect point. So calc go to intersect, which is number 5, enter, 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 and it will find that point for us. So that's going to be 6.93150. So part D. So you have to remember what that was. I've got a bad memory. 6.93. So when x of t equals 150, t is equal to 6.93 seconds. And then the last bit is explain why the body of the function is decreasing for all of t and the velocity is always decreasing. Well, we have to go back to our sign diagrams. Now, we know that when we have opposite signs here, then the speed's actually decreasing, and that's going to be for all of t. And then we know that when we've got the velocity gets determined from the acceleration equation, and we know that's negative, which means that's always decreasing. I hope this helps. If you need some more help, make sure you catch me in class. Thanks for listening. Bye for now.